Hey, I'm Brandon Cross from Hoyack. Today I'm going to talk about the future. What does it look like very soon? Now, this is a kind of philosophical, speculative session. So, not everybody's going to necessarily agree with what I see, but I'm going to give you the sight that I have so that you can kind of mix that in to the things that you're thinking about. Before we get into the future though, okay, we want to talk about the past, all right? So I'm going to put a little timeline up here, and I always love to kind of talk about the past a little bit because it's easier to kind of go through and it sets up for what the future is, okay? So in the past, like in the context of this future I'm talking about, I'm really talking about what technologies that we're experiencing today and how those technologies are going to play out. So let's just say that right now this is today, okay? And today is obviously 2025, and we're experiencing this big LLM revolution, which we kind of saw the LLM revolution happen pretty recently. Okay, it was this kind of big moment, I would say, one of the biggest moments in history, in my opinion, that we've gotten to live through, and we've lived through some big moments. But I want to go back a little bit in time before I go forward in time. And I want to talk about those big moments in the past that are similar to this LLM revolution, okay? And that's in the context of like technology. So we had, one of the big things that happened before the LLM revolution, I would say it would kind of be back to right around 2007, 2008, I'm going to call it 2010, okay? So like right around like 2010, we had the cloud, all right? And so the cloud was this huge technology revolution that sort of changed everything for all of these tech providers and the consumers of technology. Because obviously we know the cloud, everybody knows the cloud, the term cloud is very common now. But in 2006, the word cloud was starting to come about. In 2007, I remember walking into, it was at the time, there was a local company that provided like managed servers called Rackspace, and this company had started like many years before, and basically if you had like an app or something that you were running, some kind of web application or something like that, they would host your servers inside of like their data center, and then they would manage the servers for you. And so that and that sounds a lot like the cloud as it is today. The cloud was a little bit more advanced than that, more programmatic access to infrastructure and things. But truly, the thing that we experienced at that moment was that we could do this thing where we could do, like, in the past we had to build our infrastructure in steps, okay? And so it would be like we had to plan for, okay, what did our capacity need to be at this step we wanted to get to? In the cloud, we could just surge, as we needed to. We didn't have to plan for capacity. We could also surge the other way. So the cloud allowed for like bidirectional surges up or down. We could reduce the size of our infrastructure. We could grow the size of our infrastructure by turning a knob. Prior to that, you had to like do a requisition and say, I need a requisition for the amount of servers that I'm going to need to handle the load that we're expecting. And so, of course, the investors and whatnot would say, okay, what is our growth curve going to look like? And our growth curve is expected to look like this. And so we need to plan for being here. And by by this time frame, okay? And so that was, but now that the cloud, that wasn't the case anymore. So it allowed for so much flexibility, and that really, really grew what was, out there in terms of like people that could launch apps. The barrier to entry was now you could allocate your servers for your app with a few clicks, and many times those servers were like free. So you would have like this small amount of money that you would have to pay versus this much bigger amount of money that you would have to pay. And then you could scale that up or down as needed. And of course, with the rapid deployment of these things, you could programmatically activate something, and then you would essentially immediately be able to have that resource. You didn't have to wait for the requisition, the distributor to get the purchase order, the shipping of the equipment, the receiving of the equipment, scheduling it to be stood up and set up and configured and tested, everything else. All of those things had to happen over the course of time. So putting in servers, you couldn't just be like, I need more servers for my surge capacity tomorrow, and I need a bigger network pipe, and I need more storage, and I need like all this extra performance and everything like that. You couldn't do it. So, and in the past, since you were building these things this way, many times you were doing this thing where, like, if we go back in time, before the cloud, we find, like, I don't know, right around, we'd really have to go all the way back to about 1998 or so, I would say. In 1998 was when you had the release of Windows 98. And Windows 98 was a revolutionary platform many people don't remember. Now, I recall before that, I could even go way further back, and I will. Prior to that, though, and I want to say this was when things really started to happen. It was right around the Y2K, because in here you had this there was like this Y2K thing going on. So there was like a lot of spending happening inside of that window. But what happened is Microsoft came out. This is basically when Microsoft really started to push this thing called NT 4.0, and that was essentially a server that you could install in your business, and it had all these services attached to it, like your file services, and you could install your database servers on it, and your application services, and it had, user authentication services. And so it had a bunch of really cool things that like most businesses had never had access to before. And the Windows 98 system and NT 4.0 workstation at the time also really was it played in heavily to this. So now, of course, like right after that, you had the release of Windows 2000, and then subsequently the releases thereafter. In many cases, most of the operating systems that are running Windows are going to be running, some fairly modern version of Windows Server. All right, but it's all based on this old NT. It was 3.5 first, but then like NT 4.0 was when things were really hopping. And what happened there is that so many organizations were like, they had to buy, there was all these software packages that ran on Windows, and they really ran well on, somehow or another, don't ask me how, I'm not sure about this, but Microsoft positioned these software vendors very well for this platform. Many of them, I guess, were we could go further back in the past before this moment, but this, I would say, was a big moment, okay? You had, SQL Server, Exchange Server. Those were huge systems that people were deploying all the way back then, and they were moving from MS-DOS based systems, or if they had anything like that. It was a lot of the smaller offices because when you go back even further in time, before this paradigm, you really had like this world of Unix, and you had like these big mainframe systems that people were using, and so they were really, really heavy. They were very expensive. You didn't have what was like at the time these really simple network protocols that allowed for real convenient like network stuff. You were doing like back then you were still using dial-up modems for most things, but you were starting to get into like the regular internet, starting to get into deploying ISDN circuits and different kinds of original internet circuit technology, DSL and all this stuff. But prior to that, you really had these Unix-based systems that were more tied into like, Unix and Xenix and mainframe style stuff. So, Unix kind of like really went down a bit, somewhat, when this started coming out but the markets were different. The mainframe marketplace and this market wasn't always like, they weren't always comparable, right? And so you had this like open source movement happening, and then you kind of had the Microsoft movement. And so the Microsoft movement, I think, was really, really, really big. And way back here, though, these were technologies that that were the very first technologies going into things like banks and stuff. And we could go and ask like what the killer app that really started this whole thing was the spreadsheet. I'm not going to get into that, but essentially the spreadsheet was like an unfair competitive advantage that organizations started to get. And then when they moved into these newer other systems where they said, we can't afford a mainframe, we need a personal computer or a PC, then you could do something like buy the Office suite with Excel or the Lotus 123 and all this stuff. And so, those would run like, there was like, I guess DOS versions of Lotus, I'm pretty sure, if I recall. But I don't remember there being maybe a DOS, I don't remember there being a DOS version of Excel. But yeah, so that's what happened, right? And so you had like, here you were buying as if you were buying big systems, but here you were buying the same system bigger and crazier and, with this newer technology, right? And so I think NT stood for new technology, if I'm not mistaken. Correct me if I'm wrong. So this was pretty big. But you had to buy the servers and install them and buy lots of them, and they would break down, and you had to have redundancies and backup systems and all this different stuff, right? So this was this was just way too expensive. This was really expensive, and so as we start moving this direction, the technology that we're running inside of these stacks, they've really, they boiled back down to the cloud, okay, at some point. And before this, there was basically like nothing at all that you could really reasonably get into. All right, so now we move forward in time a bit, and we move a little bit past the cloud, and like people have been using their systems for a long time with standardized sort of input methods, okay? The keyboard, the mouse, things like that. But what happened when the iPhone came to market? Okay, there was like this point in time, I'm gonna say it was like before the cloud. I don't remember the year the iPhone really came to market, but the iPhone came in, okay, and there was this kind of big revolution for these mobile devices, and starting that is really where we started to take a shift away from your traditional PC and put more and more of our important work on our mobile devices and these lightweight computer systems that didn't have traditional input methods like keyboard and mouse, okay? And so like there was, you had some voice stuff. It wasn't the greatest early on, things like that. But that was where like these revolutions started to occur. And so now fast forward along, and the smartphone revolution definitely sort of continued. And it really leaned into the cloud, because obviously like every app that the smartphone was running was always running on the cloud. And all the data that those things were storing, you were usually storing on the cloud. So connectivity to things became much simpler, and technology kind of got more contiguous. All right, and so, but that still leaves us with is a lot of organizations where, like, between 2010 and like 2022, I would say ish, 2023. Between there's like this 12-year gap, okay? And so what happened in that 12-year gap, right, we had the housing crisis happen, right in the midst of that, we had like the big Great Recession going on, and then, we started to and then we had like COVID hit, really bad, kind of blocked some stuff up. But there was like this point in time, this like sweet spot point in time where it's like you had all these organizations that have like that still had remnants of this legacy technology, and then a lot of them had maybe moved into the cloud, because the cloud took some time to really take over things and push these types of other systems out. They weren't like just immediately pushed right out. So as the cloud sort of continued taking over, now we get into this really interesting new paradigm, right? The new paradigm is the LLM, okay? And so now with this LLM system, all right, I'm not sure how to represent an LLM, but I'm just gonna put a person here as the LLM. And this is like the large language model type stuff, where it enables this AI. Actually, I'm gonna do something, I'll just do AI here, okay? So AI comes into play. Now, we've always been talking about AI, way back here, okay? Now, AI has been embedded in this whole thing. There was AI-related systems back in the mainframe days. I mean, I think, if I recall, in the Karras book, they cover a lot of the history of AI, and way back in, like, even all the way back to the 1950s, have been concepts related to kind of artificial intelligence systems. And in the 90s, there was a bunch of really interesting AI tools, like Dragon Naturally Speaking was one that you would commonly come across in offices or private homes, where it had the ability to infer your speech. And these were on very old chips back in the day. It was really, really slow, and it wasn't that great, but you could speak a book into the computer in the 90s. And there was the post office, I believe, in the mid 90s, maybe it was the mid 90s, may have been prior to that, was implementing character recognition, or OCR technology, and reading I think it's the zip codes to sort mail to. And so they could run all the letters through, and this little camera would look at the handwritten zip codes, and they had a model that they trained with a neural network all the way back then that enabled for reading the OCR, determining the handwritten 1 through 10 basically, and so, or 1 through 9 digits. So then it would figure out, okay, yeah, this is the zip code for that, sort it and everything like that. So that was all the way back, and like so long ago, it seems like now, but these technologies aren't new. They've been around for quite some time. And in here, you had a lot of machine learning related stuff. So I think like some of the ML paradigms started really popping up in here. I really noticed machine learning kind of started because you had more access to the cloud, you had better GPUs, but the thing that really, really drove this down, it made this really, I think it depressed the machine learning model a little bit, was the Bitcoin revolution, which you could then, you could put that like right here, right here. Bitcoin happened right here. And so, you know, I mean, it was a little prior to that, but I can definitely tell you that, like, you know, 2007 was when I started coming across the concept of Bitcoin, and there was, it just, you know, that road across that. There was the housing crisis depressed it, then the Bitcoin stuff hit, the mining started really taking off, and mining started to just consume all of the GPUs, so nobody could really get good GPUs hardly at all unless they just paid out the nose for them forever so that they could do machine learning training. And machine learning training back here was doing sentiment analysis and, you know, basic types of inference and things. So you weren't doing, like, you weren't talking to conversationally to an LLM that was trained on some massive corpus of information. But using the cloud, you know, that's when a lot of these providers started building these scraping servers, and they started just scraping the internet, right? Because if you say like the general internet, okay, then these scrapers were just going after as much of the content on the internet as they could. Now, I know about this because I was part of that. And so, like, I definitely was involved in, you know, performing data extraction at scale. And one of the technologies that I always really was proud of was my industrial grade data extraction technology that could just take whatever public information I wanted at whatever scale, no matter how much different aggregation it took, and no matter how big part of the internet I wanted to capture. It was just really what the refresh velocity for the time series was going to be was the only thing holding me up. And so, like, this is where, you know, you started to have that happen, okay, right in there. And so so these huge databases started to get built off of that information, which then became what trained the LLM, okay? So the training data basically was part of all of this. Now, this is still going on, and now the internet's trying to resist it. It's trying to push back up against that, because it's like, we don't want all of this information being, you know, because when these things are running, they're like putting a big load on stuff, and it just knocks the servers down, or it just increases the amount that you have to scale your cloud to be able to handle it. So it's like the people that were having the data extracted from them were essentially paying part of the cost for the data extraction. Now, you know, this was like, you know, everybody wanted to extract everything that they could, and not everything was even like fair game to be extracted, especially systems that were behind password protected stuff, or behind, you know, that had specific terms of service and things like that. And so, like, depending on how that was set up, just depended on what they could do. But there were companies that, like, what I did on this stuff was like just a drop in a bucket compared to like the big guys. Like, I mean, they really, really went after a lot of that. You had Facebook that was able to like mine themselves. OpenAI did this. They built like the biggest, nastiest system ever of this stuff. And that's how they originally trained ChatGPT. It was just massive scraping. Anthropic, I believe one of them, I think it was Anthropic, trained, I believe, Claude, by purchasing a copy of every book that they could possibly buy that was in existence. And then what they did with each one of these books is they actually physically tore them apart and fed each page into a scanner that then was used to train the models. So this wasn't just internet scraping that was bringing stuff in. This was like libraries of physical books that were also just being, you know, burned to train, you know, these models. And so, you know, and that's still stuff that's like kind of sort of going on. Now, you know, and then, I mean, there was all kinds of sources. Any source that you could get that you would bring in for model training to generate this AI. And so these were what would be considered to be frontier AI models, okay? So right here was the very beginning of the frontier. And so we're actually at the start of the frontier of AI, and these things have just gone crazy. At first it was just, you know, text, and so these things were using like natural language processing type kits. okay? And then we started adding like computer vision to them, and so on and so forth. These are inference type problems. They're not regression. They don't really relate as much to regression. But then, doing predictive analysis and stuff like that. Every type of machine learning paradigm started to get collapsed into, these big models where it's like every paradigm. So that's where we talk about multimodal that's popped up. So the multimodal concept is like, I'm able to talk to my AI by using my voice. I'm able to show it video. I'm able to show it images. It's able to detect and infer things from all those sources, from text. And so that's kind of the idea. It's almost like a multimedia experience for the AI. It provides a multimodal interface for you to communicate with it by. And so now with all of these cool things and the ability to handle all this data, then now we start to get into, what's the next thing, right? And so now a lot of these things are talking, now we're going to start to get into kind of catching up to where we are, right? And so they started to build, they basically needed new ways to interface with these things. So we came with the concept of MCP servers has come out, and that essentially is an interface between like a programmatic interface, a standard API, application programming interface, and with a with the AI model. And so in that case, you have like these MCP servers that are popping up, and they're literally talking to some API, and the API is they're able to communicate with that, and then the LLM is hooked up to the MCP, and it's making queries to it, and then determining actions and things like that. And those actions can oftentimes be now with the next step, which is the tools. Okay, because if an LLM wants to use like an API to run a search or query for something, or push or pull against something, flip a switch or read some information, it doesn't know how to do that with that API. It doesn't just automatically know, right? It's like it could figure it out if it had to, if you really let it. It might make mistakes along the way. You don't have time for that with these things. You have to have the AI know how to communicate with your remote API, and you need it to be able to do it accurately every time, and you need to be able to do it securely so that it's not doing stupid things. And so thus the MCP, so now the LLMs need to be able, that's where the MCP concept came in, and then the tools, okay? So with the tools, those start to get attached as programs that can run that are associated with that the AI knows how to activate. And so depending on the response that it gets from the MCP server that's talking to the API determines what tool it needs to call. So it calls a tool, and the tool performs an action. Maybe it performs an action on another API or something like that. Okay, maybe it goes and maybe it's a scraping tool and it goes and scrapes some data, or maybe it who knows what it does, right? But it's a tool that needs to be executed. It's basically it's like we're talking to one API here, and now we have a tool that we've made that's going to do something, and that tool could be another MCP server, okay? Because like you may have a dedicated tool for some specific API, but generally speaking, you're going to have like the MCP talking that way, and then another MCP server down here. So a lot of times there's going to be like an MCP layer right here as well that it's going to talk to. It's going to really work with the tools and things. But the LLMs can call tools. The AI agents call tools. They're like, I need to use this tool. And so like, and of course, in addition to that, like all this training data is great, but like, what about if I need like a small amount of training data just for me, right? And so like this concept of RAG, okay, came into play where like we can like slide a shard of information into our AI and we can tell it, oh yeah, this is here's a little bit of information for you to use as context in this conversation, all right? And so now as this has continued, what's happened is that we're getting into this thing where we're getting better memory, okay? So the AI is able to remember more. The AI has tools, right? So it's basically got all of these cool tools now coming out of it that can attach to and do different things and twist and turn stuff and whatever. okay? And it can remember context, right? It has better, bigger context than ever. And so now the next big thing, and so this is kind of the big, like the big final opus of where I see this stuff is going, is where we get into these things called operators, okay? And so the operator is essentially, it's like a robot, all right, AI. And I mean, after that, we start to get into the actual robots, okay? That can just, where you just have a machine learning model where you hook it up to a machine and you throw a ball at it, and the machine's never seen a ball get thrown before, and it's able to think to itself, I need to catch that, and figure out how to manipulate the servos that it's got to actually grab that. And so like that's like where it just, that's the very near, that's like not too far off future, but the really near future is the operator. An operator concept is the AI that's able to use a computer like a person. So the AI is able to look at the screen using multimodal technology, and utilizing RAG, it's able to understand the context. And then using its bigger trained model, it's got all the major knowledge to look and say, this screen, I have a screen here, and it has it has like a menu on it, and it has a button, and I'm going to push the button, and up is going to come, here comes a bunch of other things. And so you might say, like, you might give an AI a task, create an invoice using my accounting software, okay? Simple task. The AI is going to have to go in there and start to look around in the computer. What's my task? Create a invoice, okay? I'm on this computer, I'm on this thing. How do I do this? First off, what am I even on? I'm on a computer. It's got some kind of navigation menu here. Let's see what's on this navigation menu. Start to read the text in the navigation menu. And then, this is a navigation menu to see what programs I have. That would be useful. It's able to figure out how to position the mouse with the XY coordinates and put it over that button and click and see what happens. Oh, well, a menu popped up. Something changed. Okay, let's reassess. And then it figures out in this menu is some software that it can reference, and this and that and that and that. There's QuickBooks. This is accounting software. Okay, so then it has to open up QuickBooks, right? And so now it gets the QuickBooks program opened up, and it may say, this has a username and password it's asking me to log in with. So I have that in my context RAG stuff, or I have a tool to look that environment variable for myself up so I can bring that secret in. Let's try it. Boom, logged in. Wow, this is neat. Now what? Now I need to make an invoice, and I'm in accounting software. So what would I use to do that? I guess it's going to be some kind of function of accounts receivable, because it's an invoice. So how do I access accounts receivable in QuickBooks? Well, I'm going to look up, maybe I can go and run a search with a tool and read the QuickBooks documentation real quick and see how that would be done. Okay, it says I need to go here and do this and do that. Well, let's go and do that. So then it starts to find the menu items and click on them. It knows kind of what it's looking for. It sees what it got access to, and it's able to move the mouse and click and do stuff and determine in a deterministic way. It's able to say, is this true or false that I did this thing or not? And then depending on that, it's able to send, okay, yeah, I did it. It's like good, or I didn't do it. And it's like, okay, well, that needs to go to like a human for further review. So that's kind of the whole picture of like what I see right now coming. Now, I could go into the final little thing I'll leave this talk with is the quantum computer narrative, and that's a whole nother conversation. But essentially, the quantum computer is going to create. We have highly inefficient machine learning models. As great as they are, they're not efficient, and the quantum computer is going to make them exponentially more efficient. And that is where we're really going to get into this very advanced robotics capabilities, I think. And we're, obviously there's the edge technology that enables those. So I could go on and on and on with that. But that's where we are. That's from all the way the 1970s mainframe systems all the way up to the future of quantum computing. I'm Brandon from Hoyack, and this has been Whiteboard Wednesday.